start sharing and take it away.
Okay, yeah, thank you. Hello, everyone. Let me share my screen first. So today I would like to talk about Kubernetes secrets and Azure Key Vault as secret storage. But before that, let me quickly introduce myself. I'm Dmitry. I'm working in KPMG Norway in digital platforms department, cloud specialist team, which is led by Anders Eide. I have more than 10 years experience with IT and implementation of digital solutions. I have been working a lot in IT, product delivery, customer success teams. My main orientation is Microsoft product stack and Azure cloud. I have been a DevOps engineer for last years, working with Azure Kubernetes service, and this area where I'm focusing on most now. Today we will talk about the Kubernetes secrets. We'll do overview how Kubernetes secrets works. I will do the introduction to the Azure Key Vault, overview, what features it has, integration with the Azure Kubernetes service. I will do the short demo for you, and we will talk about the best practices, of course. So let's start. Secrets are already a fundamental building block of the modern software development lifecycle. Applications, CI/CD systems, API access databases all require some form of secrets, tokens, credential in one way or another. Secrets are literally involved in every single stage of the SDLC. Regardless of it is sensitive or not, anything can be considered as secret. Typically, secrets include passwords or API keys or tokens. It can also be a username or any other type of plain text data, such as a parameter or environment variable, and so on. Secrets are anything that you don't want to be seen by the naked eye or to appear in the logs. The concept of secrets refers to any type of confidential credentials that require privileged access. These objects often act as keys or methods of authentication with protected computer resources and applications, tools, or computing environments. When you work with Kubernetes, you still need to use secrets in application, and Kubernetes has its own object called Kubernetes secret object. It is a special object which aimed to store sensitive data. There are two major ways in which Kubernetes secrets can be consumed by an application in a Kubernetes environment. First, secrets can be mounted as data volumes inside the pods. And second, secret can be exposed as environment variable inside pods. Then within the pod, application either can read the content of the secrets by reading the content of the file, or you can read the value of environment variable that is exposed inside the pod. Kubernetes out of the box provides several pre-built-in secret types, such as OPAC secrets, basically the user-defined data, service account tokens, credential for basic authentication, credential for SSH authentication, and the TLS type to store certificates. As I stated before, a secret is an object that contains a small amount of sensitive data, such as a password, token, or key. In Kubernetes, secrets is limited to 1 MB in size. When you create a secret, a key value pair record is being created in etcd component of control plane of Kubernetes. A key value pair record includes a secret ID field and secret data. Kubelet process that runs on each node in a cluster and manages pods and their containers uses this secret ID field to identify which secret value must be provided to an application container when creating a pod. By default, in etcd, secrets stored in unencrypted state. And of course, there's a way how to secure them, and we will speak about this later. How we can create secrets in Kubernetes? There are two ways how we can do that. First, we can use the kubectl command, create secret, to create the secret directly, or we can apply the Kubernetes manifest file. As you can see from the first example, it's a command line. We will create there a secret type OPAC, which is the default type, and secret value defined through parameter from literal. So running this command will result in create an object in secret object in Kubernetes. In other way, we can create the same secret using manifest file, which contains description of the secret resource. With Kubernetes manifest, the configuration are base64 format encoded, which means that secrets are not encrypted. Anywhere where you save the Kubernetes manifest, it will be in plain text, which will end up being a security concern. It means that with either option, you must pass value to secrets in plain text, basically. In both method, an API request will be made towards control plane, and a secret object will be created in etcd. Okay, now we know how to create secrets, but how application can consume secrets that we created. Once secret were created, we can mount them as a volume to pod, or we can map them as environment variable inside the pod. So application that you develop can use them. Here we have two examples. In case of mount secret as volume, we are defining the name of the secret object in Kubernetes and path inside the pod where file with secret will be mounted. In example, we will mount secret named ssh-key-secret to etc/secret volume directory. After that, your application can simply read the content of the file with the secret that is mounted inside the volume. In second example, we will mount a secret named backend-user as environment variable named secret_username that will be exposed inside the pod. After that, you can refer to this environment variable in your application config file. While Kubernetes secrets are relatively simple to understand, there are many factors to consider when deciding how they will be managed and injected into containers. An application configuration will likely vary between deployments, like staging, production, development, environment, etc. The use of secrets in files has its weakness and bringing challenges to us, such as, should we check in the secrets in your version control system in plain text? If so, how to encrypt them since they are secrets? If not, where to store these files? What if secrets files are scattered in different repos? Where is the single source of truth in this case? What if you deployed new application and old one is deprecated? Will you remember to delete all secrets from Kubernetes? All this challenge pushing us to find a secret vault manager solution, which can help us to solve the problem we have pointed. And Microsoft already have such solution. It's Azure Key Vault. Azure Key Vault is a centralized cloud service for securely storing and accessing application secrets. Key Vault helps you control application secrets by keeping them in a single central location and by providing secure access permissions, controls, and access login capabilities. With Azure Key Vault, we can do secret management, key management, and certificate management. Azure Key Vault will bring the next benefits to us. Centralized application secrets. Centralizing storage of application secrets in Azure Key Vault enables us to control distributions of secrets and greatly reduces secret leakage. Securely store secrets and keys. Azure uses industry standard encryption algorithm and key lengths. Access to Key Vault requires proper authentication and authorization, and the authentication is done via Azure AD, and authorization may be done via Azure Airbag or Key Vault access policies. Azure Key Vault can be integrated with other Azure services like Azure SQL databases, Azure Kubernetes, Azure App Services, and etc. Access monitoring and control. You can monitor how and when your keys and secrets are being accessed by enabling login for your vault. You can configure Key Vault to archive logs to storage account, stream it to the event hub, or even send log to the Azure monitor. High availability. We can replicate the content of the Key Vault within a region to a secondary region. Data replication ensures high availability and takes away the need of any action from the administrator to trigger the failover. Scalability. You can scale up on short notice to meet application usage spike. Simplified administration. Key Vault makes it easier to enroll and renew certificates from public certificate authorities. Encryption of data in transit. Key Vault enforces TLS protocol to protect data when it's traveling between Azure Key Vault and clients. We can integrate Azure Key Vaults and the Azure Kubernetes service and use it as a secret store provider. Azure Key Vault is a more secure method to store and manage secrets in Kubernetes and particularly in AKS. With Azure Key Vault, secrets are stored encrypted at rest. The secret store provider and secret store CSI driver are components that use in AKS to work with Azure Key Vault. Azure Key Vault acts as the source of truth of the secrets, and pods can use these secrets as volumes through the secret store CSI driver. Your application then can read the secrets data from volume mounted inside the pod. And this is great, but remember that your application should have the possibility to read the content from file and use these secrets. We solve a few problems by using Azure Key Vault with AKS. Applications that require Kubernetes secrets can access these secrets the same way as regular Kubernetes secrets. Applications that require values to be stored as environment variables can have the secret mounted as an environment variable. And other non-pod based services can access the secret the same way. All the secrets are stored at rest in Key Vault is encrypted. And Key Vault remains the source of truth for the secret, so you can update the secret in a single place and roll it out to all your clusters. Initially, AKS doesn't know anything about which secret Azure Key Vault have and which secret AKS can use. Before we can use any secrets from Azure Key Vault, we need to describe the secrets to our cluster. For that purpose, we can use secret provider class document in Kubernetes. Inside secret provider class, we specify which secrets will be available within the Kubernetes by adding records in object section, as shown in an example. And later, these secrets can be mounted as volumes inside pods. We also can expose secrets as environment variable, but it's not very straightforward. First, inside the secret provider class, we define a secret object section, which list of secrets that need to be synchronized with the Kubernetes secret objects. And second, in AKS, we need to synchronize Key Vault secrets into Kubernetes secrets objects. For that, we need to mount the secrets at the volume to the anypods, and Azure Kubernetes service automatically will sync the secrets to the Kubernetes secrets object. When you delete the pod, for example, this secret will be automatically deleted from the Kubernetes. Let's briefly look at the case when you need a TLS certificate as a secret. A good example will be using Nginx as ingress controller in AKS. And you need to have a TLS certificate as secret, which ingress resource can use for TLS termination. We can sync TLS secrets the same way as I described previously. The small difference is that we need to set object type equals secret in object section of secret provider class. After creating secret provider class in Kubernetes, we can mount the volume to the Nginx pods, and TLS secret will be automatically created within Kubernetes. Then inside the ingress resource, we just simply refer to the Kubernetes secret object. So how AKS authenticates against Azure Key Vault? There are three main methods we can use to authenticate against Key Vault from AKS. First, Azure Active Directory pod identity. This method is in deprecation and will be replaced in the future. In this method, each pod will use pod managed identity to access Azure Key Vault. Azure AD workload identity is the newer method or newer version of Azure AD pod identity. Azure AD workload identity for Kubernetes integrates with the capabilities native to Kubernetes to federate with the external identity providers. And the third method, you can use user assigned or system assigned managed identities. And we will use system assigned managed identities in the demo, and I will show you later. So what is the best practices? Secrets like keys, passwords, tokens, and other configuration values must be stored correctly. If our Kubernetes cluster is compromised, the secrets must remain secure. An attacker should not be able to exploit secrets to compromise sensitive data, build a botnet, or command and control servers. Here are some techniques to help us keep secrets safe. enable encryption at rest, Kubernetes secret data is encoded in base64 format and stored as plain text in etcd. etcd storage, it's a special component in the Kubernetes cluster control plane. Storing secrets as plain text in etcd is risky, as they can be easily compromised by attackers and used the access to system. One way is to harden security of etcd data is to encrypt secrets before storing them. We can use an encryption provider such as a key management service to encrypt etcd with custom encryption keys. It is good to know that most of the managed Kubernetes provider encrypt etcd by default out of the box. Next, configuring of airbag rules. Encrypting Kubernetes secrets at rest is only part of what required to keep secrets safe. You should also control access to secrets using airbag rules for Kubernetes. The security policy authorizing access to secrets can be task-based, time-based, or role-based. And the third is use a centralized secret store for easy management. A cloud-based tool such as Azure Key Vault is a proper secured method to store secrets. So I would like now to do the short demo for you. And I have a pre-configured or pre-created cluster. And I would like to say that it's actually very easy to enable this Azure Key Vault integration and Azure Kubernetes service. It's a one-line PowerShell command that you can enable this integration on the already existing cluster, or you can onboard this integration during the cluster provisioning. So first, I would like to show you that I already have the Key Vault, and I already have the Kubernetes cluster. So let's see if integration is up and running. For that, we will run a very simple command. So as you can see from the command output, it's two components that I was referring previously. It's secret store provider pods and the secret store CSR driver that is already up and running. And that means that integration is established. So I have several YAML files that I will show to you. This one, I already predefined the secret provider class. And here you can see that I have two secrets that I would like to use in my Kubernetes cluster. And I have one secret that I would like to synchronize the Kubernetes secret object. And let's see what we have inside the Azure Key Vault. So if we go to the secrets page, here you see I have two secrets pre-created. It's the first one and second one. And these secrets I would like to have in my deployment in Kubernetes. So first we would need to apply this secret provider class. Yeah, so it's been created, and let's check that for that moment we don't have any secret. Good. And now I will apply the YAML file to create a simple pod. I create the definition for pod. I am using the standard Nginx image. And here I am referring to this secret provider class, and I'm using the secret store CSI driver to mount the volume, and would like to have my secrets mounted on that pod. And I would like to have these secrets to be available as environment variable. So let's apply this YAML to see what will happen. Yeah, so what is created? Let's see the status. Yeah, so it's up and running. Now we can try to SSH into the pod to see if secrets are there. Yeah. And if we will navigate to MNT directory, it's the directory where I'm referring from this YAML file. So yes, we have this directory pre-created already. And here we can see two files that's actually secrets that were mounted. So let's see the content. So the value of this secret is mount me as volume. And let's compare what we have inside the Azure Key Vault. Yeah, so this is the value of the secret, and we can see that we have it inside the pod. And if I would have some application that required the secret inside this pod, I can just read the content of the file. But we have a second secret for the environment variable, and let's see if we have an environment variable exposed. And as you can see from the output inside the pod, the secret was already set. And let's check the value inside the Azure Key Vault, what we have there. So we see that it's the same secret. So it works. If I would have the application that I need to use the secret from environment variable, I simply will use this environment variable in my config files. And what we need to check as well, as I stated before, in YAML file, we would like to synchronize this secret as a Kubernetes secret object. So let's see if we have this secret as environment variable as the secret object in Kubernetes. kubectl get secret. And as you can see, the secret was created properly by Kubernetes. Let's do one more step, and we'll see what will happen with this secret after we will delete the pod. Let's check if we have a secret. No, as you can see, the secret was automatically deleted by Kubernetes. So it means like if you are removing some old deployments that is not in use and you have the secrets linked to the deployment, they will be deleted as well. Yes. And the last thing that I would like to show you how we authenticate against the Key Vault. So here in service provider class, we are defining the client ID of the managed identity. And when you enable the integration for the Azure Key Vault and AKS, the managed identity will be automatically created by Azure for you. So here I have this managed identity, and I simply using this client ID in my YAML files to point that Kubernetes can use this managed identity to work with Azure Key Vault and fetch the secrets. Yes, so that's everything that I have for today. Hope that this was not very boring. That is my first presentation is in such events, so to say. And if you have any question, I will try to answer.
Yeah, we got a hand up from Marcin. Marcin. I'm not sure I'm going to pronounce your name, but I can probably do a better job on that myself.
Yeah, I can. It's Martin. Anyway, yeah, I work as an architect for at Central Bank in Norway. Quick question about TLS certificates and Nginx. Can you use your because you mentioned that they would be created automatically? Can you provide your own key, bring your own key to the mix?
You mean, can you use bring your own certificates to the Key Vault?
Yeah. Yes.
Yeah, sure. Yes, definitely. Yeah.
Oh, okay. Yeah. Thanks. That's the question.
Yeah.
And by the way, great presentation. Thank you.
Thank you. Yeah. Of course, you can bring your own certificate to the Azure Key Vault, and then you will create the secret provider class with this TLS stuff, and you will mount this secret inside the Nginx pods. Then these certificates will be available within Kubernetes as a secret object, and it works. I tried it a couple of times in my previous job. Yeah.
Great. Makes it a bit more secure.
And
At least when you think about access to your data for anyone else outside of your company.
Exactly. Not only that, I had experience previously where we had a lot of different deployments that were using the same certificate. And then when it was time to replay the certificate, that is a tons of job to update this certificate to each place in all the deployments. But here, when you use this Key Vault as a central storage, you just update the certificate here in the storage, and then it's automatically updated on the inside the Kubernetes. Because Kubernetes, it's polling every 5 minutes, if I'm not mistaken, to pull the changes from the Key Vault, if it's like secret was updated or something like that. So it's like great stuff to manage your secrets in addition to the security stuff.
Right. So if your own secret S2 you would just get pulled all the time and replaced, renewed.
Yeah, it will update secrets if you update the secret in the Azure Key Vault. It will be updated automatically in Key Vault. Except it works for the volumes, but like if you have this environment variable exposed to pod, then you need to restart the pod to refresh the value of the secret inside your pod. Volume will be updated automatically with this polling every 5 minutes from AKS side, but environment variables need to be updated manually, or you can actually use some third-party tool to restart the pod by schedule or something like that.
Yeah, I guess you can automate the process.
Yeah, I think in Microsoft documentation, it's actually the tool that they recommended to use to automatically update these pods with secrets that exposed as environment variables.
Okay, thank you.
Yeah, you're welcome.
Any other questions? By the way, very good presentation, Dmitry, and very effective and nice demos, which showed exactly what you wanted, I think. So
thank you very much.
We will share. You can send us the either directly to me or via Anders the presentation, or you can just do a pull request to our GitHub repo yourself. If you can share the presentation you showed. And also the recording will show up on the Azure User Group Norway YouTube channel, which you will see through other Meetup page. And I'll make sure I share it with the attendance here afterwards as well. So if not any other questions, I think we will say thank you for all attending, and thank you again to Dmitry.
Thank you. Yeah.
Thank you.
Have a good day, everyone, and good summer.
Have a good day.
Likewise.
Yeah. Bye.
Have a good one.
Bye.
Bye-bye.